Dear students, for 6th semester BSc Mathematics under Mangalore University, we have two papers. One is a common paper and the other one is optional paper. Again, there are two papers under optional, of which we are going to discuss the paper graph theory. Graph theory is a very important subject. It is interesting due to its simplicity and wide range of applications. In the last three and a half decades, graph theory has grown significantly. There are many applications of graph theory to a wide varieties of subjects such as operational research, physics, chemistry, economics, genetic engineering, computers, and so on. You look at the questions. How can we lay cable at minimum cost to make every telephone reachable from every other? What is the fastest route from the national capital to each state capital? In what order should a traveling salesman visit cities to minimize traveling time? Can we color the regions of every map using 4 colors so that neighboring regions have different colors? These problems can be efficiently handled with the help of graph theory. Right? Now the question, who initiated this and when? The first paper in graph theory was written by Leonhard Euler in 1736 when he settled the famous unsolved problem of his day known as the Königsberg Bridge problem. Königsberg is a city situated in Russia. There was a river flowing. The river was known as Pregel River. On either side of the Pregel River, the Königsberg city was situated, and there were two islands. Say island A and island B, and these are the banks of the river. Total, we have 4 land areas. 1, 2, 3, 4. 2 islands and 2 banks of the river. Okay. And these 4 land areas were connected by 7 bridges. 1, 2, 3, 4, 5, 6, 7. 7 bridges. The problem was to start from any one of the land areas, walk across each bridge exactly once, and return to the starting point. Okay? Euler proved that this problem has no solution. He has replaced each land area by a point, and each bridge he replaced by a line segment. So he got a graph here. He has produced a graph. This is a graph related to Königsberg Bridge problem. Right? Königsberg Bridge problem, what is it? Starting from any one of the land areas, whether it is possible to cross each of the bridge exactly once and return to the starting point. This problem is the same as the problem of drawing this graph on a sheet of paper, right, without lifting the pen from the paper and without retracing a line, and coming back to the starting point. Okay. The problem of crossing each of the Königsberg bridges once and only once is equivalent to finding a path in the above graph that traverses each of the edge exactly once. Okay. So this was the historic importance of graph theory. We are going to discuss this bridge problem after studying some basic definitions and theorems due to Euler, and with the help of the theorems he is answering the question of bridge problem in negative, that we shall discuss later on. In this session we shall discuss the definition of a graph, self-loop, parallel edges, simple graph, finite and infinite graph, incidence and adjacency. Okay, we shall go through these definitions. What's a graph? A graph has got two components, vertex set and edge set. What do you mean by vertex set? It is set of points v1, v2, v3, etc. Edge set of line segments. Have a look at this. Here there are how many vertices? 1, 2, 3, 4. There are 4 points known as 4 vertices. And the line segment connecting these points, these vertices, which are known as edges in the graph. Vertices and edges. For a graph, we have two components. One is vertex set and other one is edge set. Such that each edge EK is identified with an unordered pair of vertices VI, Vj. Take any edge here. This edge is identified with the vertex pair V1, V3, or this edge is identified with the vertex pair V2, V4, etc. So for a graph, we have two components, a vertex set and an edge set. Vertex set and an edge set. Look at the definition of a self-loop. If an edge is associated with a vertex pair Vi, then it is called a self-loop. What do you mean by Vi? For an edge, you are having two end vertices. One here, one is the other one. The initial vertex, the terminal vertex. For a loop, self-loop, initial vertex and terminal vertex should be same. So starting point and end point should be same. This is a loop. Okay. What are parallel edges? If two or more edges are associated with the same vertex pair, then such edges are called parallel edges. Look at this example. Between the vertices 2 and 3, there are two edges here. Two edges. These are known as parallel edges. Right? If two or more edges are associated with the same vertex pair, then they are called parallel edges. Okay. Simple graph. See, here you are having a loop. Here you are having parallel edges or multiple edges. A graph with multiple edges may be called as multi-graph. What is a simple graph? A graph which has neither a self-loop nor parallel edges is called a simple graph. Okay? A graph without loops or parallel edges. Right? Without loops or parallel edges. This is an example of simple graph. It has neither a self-loop nor a set of parallel edges. This is a simple graph. Okay, fine. Look at finite and infinite graphs. A graph is said to be finite if it has finite number of vertices and finite number of edges. Otherwise, it is called an infinite graph. Okay, finite number of vertices, finite number of edges. So this is a finite graph. There are 7 vertices. 1, 2, 3, 4, 5, 6, 7. And there are 8 edges. 1, 2, 3, 4, 5, 6, 7, 8. 7 vertices, 8 edges. It is a finite graph. Here it is a part of infinite graph. This can be continued here. With the vertices and edges can be continued. It is a part of an infinite graph where infinite number of vertices and infinite number of edges can be formed. Okay. So a graph is said to be finite if it has finite number of vertices and finite number of edges. Otherwise, it is called an infinite graph. See here in our discussion, we are restricting ourselves only for the discussion of finite graphs, not infinite graphs in the entire paper. Okay, fine. Look at the definition like incidence, adjacency of edges, adjacency of vertices. Okay. See, when a vertex Vi is the end vertex of an edge Ek, we say that Vi and Ek are incident on one another. Incident on one another. If Vi is an end vertex of the edge Ek, we say that Vi and Ek are incident on one another. What is adjacent edges? Two non-parallel edges are said to be adjacent if they are incident on a common vertex. They should be non-parallel edges. Non-parallel edges. They are said to be adjacent if they are incident on a common vertex. Okay. What is adjacent vertices? Two vertices are said to be adjacent if they are the end vertices of the same edge. End vertices of the same edge. I will look at this example where you can understand this definition very clearly. See, here you have a loop, self loop. E1 is a self loop. For a self loop, the initial and terminal vertex are coincident here. Okay. E4 and E5, it is this edge and the other edge, E4 and E5. These are described on the same set of vertices. Therefore, E4 and E5 are parallel edges. Okay. Look at E2 and E7. They are incident on a common vertex. They are incident on a common vertex. Therefore, E2 and E7 are said to be adjacent edges. Right? Two edges, two non-parallel edges. They are not parallel. They are described on different set of vertices. Described on different set of vertices. They are not parallel. Two non-parallel edges are said to be adjacent if they incident on a common vertex. So E2 and E7 are adjacent. But E3 and E7, this edge and this edge, these are not adjacent. Okay. They are not adjacent because they are not incident on the common vertex. Okay. Next, let us come to vertex adjacency. V2 and V4. V2 and V4. These are the end vertices of the same edge. They are the end vertices of the same edge. Therefore, the vertices V2 and V4 are adjacent. Vertices V3 and V4 are adjacent. Vertices V3 and V1 are adjacent. Okay, but your vertex V2 and vertex V5, they are not adjacent. They are not adjacent because they are not connected by a line segment. They are not the end vertices of same edge. They are not the end vertices of the same edge. Therefore, V2 and V5, these are not adjacent. Okay, so fine. Any difficulty in this topic? So we have just started with our optional paper graph theory. We have looked into the historical importance and studied a few basic definitions. Let's continue in the next session. Thank you.